for some reason or other, and I can't remember why or how, but it happened. We never did homework 17. So I have got homework 17, and that's going to be the first thing we're going to do, and we're going to get that over with, right? So, how do you solve radical equations? So basically, how do you solve equations with square roots and cube roots in them? That's pretty much where we are. It's actually not too bad because it does overlap a little bit with quadratic, so it's not totally isolated stuff. Here are the questions. Just going to go through each one of them, and hopefully that will cure that problem. Right, the key to solving these equations is using the technique that I use a lot, and my name for it is, as long as you do it to both sides, it's okay rule. Remember that guy? As long as you do it to both sides, it's okay rule. So what you have to do here is remember, do whatever it is to both sides, and to figure out the right order to do it as well. So the cube root of x plus 9 equals 2. What should I do to both sides to get closer to solving for x? How would you get rid of a cube root? What would you do to both sides? Any ideas? What would you do to get rid of a cube root? Well, maybe you were thinking about it, but didn't want to say it because you weren't sure. Just cube both sides. Does that seem, how do you get rid of a square root? Don't you square both sides? How do you get rid of a square like x squared? Don't you take the square root of both sides, right? It's that kind of trick. Now, 2 cubed is 8. And subtract 9 from both sides. And there's our solution. Well, we hope it's solution, but it may not work. And if it doesn't work, Weber-Sign calls the ones that don't work extraneous solutions. They're sometimes called ghost solutions. Not really there. Well, I could do a quick check. If you put -1 in here, you get the cube root. Well, let's do a check. Let's check that that's actually a solution. So the cube root of x add 9 should equal 2. Well, the cube root of -1 add 8. Sorry, add 9. That gets you 8. And isn't the cube root of 8 a perfect number? Check. So it works. So as long as you do it to both sides, it's okay rule will get you pretty much through almost every single one of these questions. Well, that was question 1. Question 2 now. The square root of 6x take away 23 should equal 11, right? What do you think I'm going to do to both sides now? Using this as a guide.
Square root.
Oh, it is a square root. So how do you get rid of a square root? You do the opposite of it. So you square it. Maybe that's what you meant. So you take this guy and you square both sides. And that gets me 6x take away 23 is 121. If you add 23 to both sides, you get 145. You then divide both sides by 6. Do you think this fraction here, 145/6, do you think it can simplify? Yeah, we should then. Let's just let the calculator do it. They're 145 divided by 6. And then I'm just going to do math. Choice 1, enter. And it tells me that that cannot be simplified. So, looked like it should. I thought it should. Ended up not. Now, I should check that that works, but I know it does. So we'll let it go. Question 3. The cube root of 2n minus 1 equals 3. Now, there's a theme to this. If you figure out the theme, these questions are pretty easy. What should I do to both sides now? What's the next step?
Cube root the 3.
Okay, then, so we're going to cube both sides. And if you cube this guy, you basically get rid of the cube root. And if you cube this guy, you raise it to power of 3. And 3 times 3 times 3 gets you 27. Okay, what should I do next to both sides? 2n take away 1 is 27. What should I do next?
Add
1.
I hear it in lots of places. And adding 1 gets me that. I'm doing the next bit because it's too easy. Divide both sides. There's your solution. And can you trust me? If you check it, it works. I'll tell you the ones that don't. Going good? Yeah. Watch the next one. It's a bit sneaky. Got a square root in it, which is not that bad an issue. Negative x add 9, a bit ugly, equals x minus 9. Now, if I had been 9 or negative 9 or 42, if the right-hand side had just been a number, wouldn't we just square both sides? Right, that's what we've done before. I'm going to do that. I'm still going to do that. I want to show you why this one is sneaky. If you square this side, the square root disappears. But you have to square both sides, which means that you've now got that. X minus 9 squared means x minus 9 times itself. And that's what you get when you FOIL it all out. Now this guy is something that we've seen similar questions to. Isn't this a quadratic equation? Right? Now I can solve that any way I like, but I want to solve it with the least amount of work. Right? So I could do it by factoring. I could, God, I hope I don't have to do it this way, but I could use the quadratic formula, which takes forever. I could do completing the square. There are lots of ways I could do it, but I'm going to try this way first. I'm going to add an x to both sides, and I'm going to subtract a 9 from both sides. And I'm going to get that guy. Are you happy about adding an x to both sides and subtracting the 9 now gets me as a quadratic equals 0? Now, the order I like to do solving quadratic equations is I like to factor them first, because if I can factor them, it's dead quick. Then if I can't factor it, then I'll try one of the other methods, quadratic formula probably. But I try and avoid it. This is an x squared, so that's good. Two numbers multiplied together give me 72. But when I combine them, I get negative 17. So the only way that's going to happen is when both numbers are negative numbers. Okay, there is a combination that works. Two numbers that multiply together give you 72, and then when you put them together, you get 17.
9 and 8.
Agreed? So far. Now, the factor is x minus 9. So the value of x that makes this 0 is 9. So there's one of my possible solutions. And this one, it's 8. There is my other possible solution. And the reason I'm going to call it possible solutions is that one of these guys doesn't work. And whenever you do a solution, you should always check out to see if it works or not. So which one of these two do you want me to check first to see if it's actually a usable one and not a ghost solution that you can't use? You want me to do 9 first, or you want me to do 8 first?
9.
9 gets the job done. So let's check x equals 9. Well, the square root of negative x add 9 should be equal to x take away 9. Negative 9 add 9, 9 take away 9. Square root of 0, 0. Hey, it works. That one worked, didn't it? Isn't the square root of 0, 0? You can use it. So that must mean the other one doesn't work. Well, at least that's what I said. So let's find out if I'm right. Well, it's yeah. So it's going to be the square root of x minus x add 9 should be the same number as x minus 9. You plug in 8, it's that fella. If you plug in 8 here, you get that fella. Square root and square root of 1, negative 1. That's not right. Isn't the square root of 1 plus 1? Right? They don't match. Can't use them. The square root of 1 is 1. 1 is not equal to negative 1. There isn't a little plus minus beside here, right? It's just a square root. And if it's a square root on its own, it means it's a positive number. So there it is, our extraneous solution. That's what the book will call it. I much prefer the name a ghost solution. Are we okay with that question? Any questions about that question? Okay. Coming up on halfway mark, number 5. Okay. As long as you do it to both sides, it's okay, rule. And that technique will get you out of so many difficult situations. What should I do to both sides here? Square root of this equals square root of that. what should I do to both sides?
Square them.
And if you square them, you essentially remove the square root. Now, would you agree that is much easier to solve than it was a second ago? Now, once you've got rid of the square root, or occasionally a cube root, because some questions do have cube roots in them, once you've got rid of them, you're now left with a kind of normal equation, right? A linear or a quadratic, typically. So you have to take each one as it comes. What do you think you should do in the next row, the next line? What should I do here? Especially here.
Distribute the 7.
Yeah. So 7 times x and 7 times 9. Yeah. What's next?
Factor the 9x to 56.
You know, take it out as a common factor. Jamie Lynn, is that what you're thinking? Yeah.
Yep.
I don't think I want to do that.
You want to get x on one side?
Yeah, I think that's a better idea. You want to get x on one side. Would that make sense? If you're going to solve the equation, right? We probably, in this case, I think, do that. I can see why you might want to factor quadratics, for instance. I definitely would want to factor, right? But not in these. These are linear. So which one do you want to get rid of? Do you want to subtract 7 from both sides, or do you want to subtract 9x from both sides? I guess you have a choice.
Subtract 7.
What do you think you would do? Okay. So if you subtract 7x from both sides, Jamie Lynn, I'm putting you in this spot here. What should I do to both sides now?
You want to add 56 to the other side?
You want to add? I need backup here because I don't know if I'm 9. I believe it's 119, but it just sounds so ugly. I want somebody to confirm that. Is it 119?
Yeah, it's 119.
God, that's ugly. Okay. Last step, divide both sides by 2. Can you trust me that that answer doesn't go anywhere? It doesn't simplify. And so it is what it is. Can you also trust me that it works? Right, I've checked it, it works. That's us done halfway. Again, any questions before we move on? Are we okay with this technique of just doing it to both sides gets you out of trouble? Squaring both sides, cubing both sides, whatever it might be. Okay. This is new. And again, it's gone to the wrong place. We are being asked to take this formula and solve for h. What they mean when they say solve for h is, we want you to take this formula and rewrite it so h equals whatever it is. And you're going to use pretty much the exact same techniques that you've used in the other questions. And that exact same technique is, guess what? As long as you do it to both sides, it's okay, Will. So when you're finished, when we're finished, h is going to be on its own. So it's all a matter of doing it to both sides, yep. But now we have to be a little bit more careful about what you do first and then what you do second. So this is 2.6 times the square root of h. So the first thing I'm going to do is divide both sides by 2.6. And I don't care how ugly that is, you don't need to fix it. You just leave it alone. B over 2.6 is just going to be the answer right now. Now, what do you think I'm going to do to both sides to get h?
Square.
So if you square both sides, there you go. Not the prettiest formula in the world, but it's done. Isn't this formula now h equals? Right, h on its own equals whatever it is. So we've just done our first formula. Question 7. They get a little bit harder. V. Oops, there I go again. V equals the cube root of 82V divided by pi. I like this question. I like ones that are kind of like Russian dolls, things inside things inside things, right? So what do you think I should do to both sides to eventually get V on its own? So it's the order that we do things as well. So what should I do first? Won't
Q.
eventually get V. I agree.
Also, is that a 17 at the bottom?
No, it's a very strange looking pi.
Oh,
It's a pi. But I can understand it kind of looks like 17. I'll try making it more curved. Does that look more like a pi or is that worse?
that's better.
I know it looks worse to me, but maybe it looks more like a pi here. So that works. Okay, step 1. Cool. Now you got a really stinkery issue. Remember, what we want is V on its own, but very often you have to do lots of other things first before you get there. What do you think I'm going to do to both sides next? I don't think this one's quite as obvious as some of the others.
Multiply by
gonna do
pi.
now? Yeah. How did you figure that out? Did it just seem right? Or what was your thought process?
I was the denominator, so to get rid of the fraction, you'd like multiply by the denominator.
Right, so it makes sense. So what I'm hearing here is if you've got a fraction, get rid of the bottom. Right, that's a good strategy. Okay, we're almost done. What do I do to both sides to get V on its own? What should you do to both sides to get V on its own?
Divide by 82.
And that's us finished. It's not really solving an equation in the sense that, you know, x equals 10. Isn't this just manipulating a formula into a different formula? But we're using the same techniques, right? We're doing things to both sides. Well, 3 more of these to do and we're done. Well, apart from some questions I'll give you. This is 8. The formula is R equals the cube root of A over T take away 7. And they want us to solve for P. Whoa, that one is going to be fun. Definitely going to be fun. Out of all the questions we're doing today, this is the hardest. Out of all 10, this one takes the cookie. This is it. As long as you do it to both sides, it's okay, Ro. But we got to figure out who to do first, then second, then third, right? It's kind of sequence. What do you think the first thing to take care of is?
Add 7.
I like your thinking. I agree with it. Okay. Every step's getting a little bit closer to finding P. Okay, what you going to do next? To
Cube
both
root.
sides? I know what you mean. It's called a cube, but I know what you mean. You cube both sides, right? I guess I could maybe write for this one what's happening in case you go back and look. So I'm adding 7 to both sides. Cubing both sides. Oh, look at that. A over P. And we're trying to get P on its own. But it doesn't really look like there's an obvious way of doing it. So maybe there's a not so obvious way of doing it. Eventually, we are going to have P on its own. Remember what Alyssa did with the fraction in the denominator?
Well, I was going to say multiply by P and then move everything onto the other side
Okay.
after you do that.
Well, let's do that because that sounds like a good plan. If you multiply both sides by P, right, now you've already mentioned, Sarah, what you should do next. Let's see if anybody else can see what you mean, because I'm pretty sure I know what you mean. What are you going to do to both sides to get P on its own? What you going to do to both sides to get P on its own?
Subtract P.
Because that's a multiplication, I don't think that would work, but I like your thinking.
Is it okay if I can give the answer?
Sure, go for it.
You divide r plus 7 with the square root. Oh, not square root, cube root.
The QB thing, that guy, right? There you go. That's the answer. Jimmy Lynn got it. But that is one ugly question. Agreed. Definitely the worst one. I would say it's the worst one out of the 10. So we've just got 2 more questions and then a couple I'll give you and I'll call that done, hopefully. Anything you want me to go over, any of the earlier questions, because I didn't pause and ask. Any of the earlier questions you're not sure how we got from line 3 to line 4 or whatever that you want me to talk about? Okay, that's a good sign. We are back. To solving square root questions. So you might think, why is this one almost the last question? Because it's in the end, you put all the ugly ones, right? Because 8 is definitely ugly. You haven't seen 10 yet, but 8 is definitely ugly. And this one is definitely ugly. 6 square root of x's equals the square root of 6x add 60. And we are trying to solve for x, right? We're trying to find out what value or values of x would this be true for. Any ideas what you do to both sides? Because that's the technique we're going to use, as long as you do it to both sides.
Square both sides.
Right, great. Now, if you square this guy, you get 6x add 60, right? If it was the square root of x on its own, wouldn't you just get x? So here's the puzzle. What happens to that 6? Does it stay as a 6 or does it become 36?
It becomes 36.
It does. Because aren't you squaring this, squaring this, squaring this? This gets you 36, this gets you x, this gets you that. Agreed? Now, once you've figured out that little trick, because the mistake that people make is putting 6 there and not 6 squared, which is 36. I don't think it's that hard a question. Would you agree? What should I do to both sides next?
Square it.
Not sure about that one. Think of solving for x. What should I do to both sides?
Get x on one side,
Okay, so how will I get that to happen?
-6 x.
So we get 30x is 60. And then I'll do the next bit because it's easy. Divide both sides by 30. And you've got your solution. And I've checked it. And it works. So we know it's good. I'll just got one more question. Here maybe. And you've got question 10. And it's d equals 1.4h. D is in miles. And h is in feet. That's okay. And if you want to know the context of this, if you have a tower, we all know that that's very badly drawn world, but the world is curved. And the distance that you can see, that distance d, to the part where the world curves, is given by this formula. It's 1.4 times the height of your tower in feet. Okay, so here is my formula. In this question, you are told that D is 33 miles. So what you are going to find is how tall does a tower need to be so that you can see 33 miles in the horizon, right? So if you've ever been in the Navy, or I've been at sea, it's kind of cool. If you look really carefully, you don't get to see forever. Doesn't the Earth curve and things disappear beyond the horizon? Now, if you're right up the top of a high mast, don't you get to see a little bit further before things disappear? So what this very simple formula does is it tells you visually how far away you can see things. It's kind of cool. Now, if the distance is 33 miles, the formula says that. I don't know why I want to do this, but I'll put a bracket around 1.4. It just looks better. Now, what do you think I'm going to do to both sides to find out what h is? What should I do to both sides to get h?
Divide by 1.4.
Right, and this is the only time that I'm actually going to not just leave it as an ugly answer. I'm going to turn it into an ugly decimal. So 33 divided by 1.4, and the answer I get is about 23 point, well, it's going to the nearest foot. So that's what it looks like. So to the nearest foot. Right. So if you were at sea and you were at the top of a 24-foot mast, you could see about 33 miles, right? So anything that's 33 miles away, and it's big enough to see, you know, if it's a little dinghy, you'll never see it, no matter how, whatever it is, if it's big enough to see, you could see it. You know, in the olden days when there wasn't radar and all those really cool devices that we've got, that a lot of people in the Navy had to just go up to the top. I think it's called a crow's nest. You ever heard that term? Do they still call it that in the Navy? Is there a place on a ship still called the crow? Do people still go up there, or is it electronic stuff up there?
They have watch up there.
So there's some poor guy or guys, and guy or guys means girls as well, who's stuck up the top there. Are you just there because you can see further, essentially?
I wish. No.
Is that the reason they put you up there? Because visually you can see a little bit further than if you were on the deck of a ship. You know, this formula here says you can see a bit further. I'm assuming that's why that. Maybe they just didn't like you and told you to go up there. Was it horrible?
That sounds about right.
Oh, is it very uncomfortable up there?
Yes, especially with the planes like fuming jet Jeff, you let you? Very uncomfortable.
Okay, well, you obviously pissed off your boss, right? If you ever join the Navy, take Rachel's advice. Don't annoy your boss or they'll send you up the coast.
Never. Yeah, don't.
So, not a good place to be, right?
No.
Gotcha. Okay, so what I'm going to do is I'm going to give you 3 questions to try it yourself. And we'll call that, we'll kind of call that good, right? Like we've done it. Right, so here's your first one. You're going to solve that one. Here is your second one. It's hard to do these when you. Let me check this one. I may have to change the number. I'm trying to make it so it comes out nice. Sorry about that. These are quite difficult to do on the spur. I like that. I'm keeping that. Gotta figure a better version of that. If it works. Okay. There's question 2. And the last one. Okay, so in the last one, you're going to rearrange that formula to be B equals. I'll give you. Okay, we'll do these 3. You can catch up with wherever you happen to be. As long as you do it to both sides, it's okay, Roll. That's pretty much how we're going to do these guys. Okay, on question 1, what should be the first thing I do to both sides?
Square both sides.
Agreed. And 7 times itself is 49, so that's good. What do I do next?
Subtract 5.
Which gets me 44. And to finish the question,
Divide by 2.
and that one works, just in case it was an extraneous solution. So that was a pretty straightforward one, right? There wasn't anything too weird going on. Okay, what we're going to do in question 2 then? What's the first thing to do to both sides?
Square it.
And when you do that, you basically eliminate all the square roots, right? Squaring gets rid of square roots. Okay, this is a quadratic equation. Why do I know that? Because it's got an x squared in it. So tell me where we go next.
Gotta put all of it on one side so we can FOIL it.
Okay, so we bring a 4x away from both sides. And a 3 from both sides, agreed? Sorry, a 6 from both sides to the 3. So I subtracted 4x from both sides, then I subtracted 6 from both sides, and we're looking like this. So when you've got a quadratic equation, right, an equation with x squareds in it, you kind of make it go into this form here. And we could use the quadratic formula or we could factor it, right? I would choose to factor it first. If it's possible, always go that route. Since it's an x squared, we don't need that magic cross. That's something in its favour. I'm looking for 2 numbers that multiply together, give me +3. But when I combine them, I get -4.
-3 and -1.
And that gives me 2 solutions. The first one is what makes this factor 0, x equals 3 makes it 0. And the second one is what makes that one equal 0, and you get 1. And now I'm going to do a quick check. Works. Works. So both of them work. I can keep both answers. I just did it in my head, but can you trust me, both work so you don't kick anybody out. Now we're left with the last question, and whoa, did I give you a tough one? I think this one's worse than question 8, which I thought was the worst question. Now this one's kind of taking the job. As long as you do it to both sides, it's okay rule. You just have to be careful about what you do first, then second, then third, right? It's a Russian doll thing. So what's going
Can
to be
you go
first?
a little closer because I can't see that one?
This one here?
Yes.
Did that help any? You see it now? You need it closer. I
It's
can't
better.
hear you. Better, okay. The thing I've got's in a funny little arm, so if I bend it too far, it actually just points over the desk.
Is that cubed or squared?
This is a cube root and this is a
Okay.
square.
Okay.
So, what do I do to both sides?
Square it.
Agreed. So if you square this side, and you square that side, so the square roots are gone. That's a good start.
Multiply by
off?
10.
I hear a multiply by 10. But remember, the final goal is to get B on its own, right? So what's next?
Divide by A.
We're that close, one step away from perfection. What do I do to both sides to get B on its own?
Square root.
That ugly guy is the answer they're after. Like B on its own. Are we good? That one was a sneaky one. Any questions about homework questions? Homework 17 questions. It's basically a list of them all. Any problems with those? Okay, then that is the end of that. Can anybody remember, and basically to remind me, make sure that I'm in the right place, where we got to a week ago, last Wednesday? I
The last
believe,
chapter was 19.
right. Were we doing using the quadratic formula? Because that's what my memory is telling me. Were we solving quadratic equations by doing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a? Does that ring a bell?
My last notes was the quadratic formula.
Right. So that's where we're going to continue today. We're going to look at homework 20 and do some more of those. The homework 20, quadratic formula. I kind of have been mentioning that today, and I'm saying, look, you don't want to use this method unless every other alternate method has failed you. Right, you've tried to factor it and you just couldn't. the numbers are so ugly you just couldn't figure out a way of doing it, or maybe it's not possible at all. Whatever it is, it ain't going to happen. Then you use this guy called the quadratic formula. What it allows us to do is to solve any quadratic equation that's written in its standard form. A quadratic equation that's written like this is in its standard form, right? So many x squared plus or minus so many x's plus or minus a number equals 0. Right, so you make sure that before you even try the question, that if it's not written in this format, that you make it become this format. Then you can use the quadratic formula. And the quadratic formula says the solution, what will x be equal to, is given by this really ugly formula. Negative b plus or minus, because there's going to be two answers, one when you use a plus and the other when you use a negative, of b squared, take away 4ac, all over 2a. And that guy is called the quadratic formula. So in one sense, it's relatively easy to use. It's a formula, right? You plug and chug. The hard part is that it's such an ugly formula, it's very easy to do it wrong. Right? It's very easy to make a mistake somewhere. There's lots of different moving parts going on here. And so I tend to do it in a very specific way and remind you how you do it. But let's just show you how it can be done. Give me any number, Rachel, between 1 and 5. Make it a whole number.
1 and 3.
Well, just pick one for me.
1.
Boring. Okay, 1x squared. Alyssa, give me a number between 1 and 10, positive or negative?
-5.
And I put the last one in. We are trying to solve x squared take away 5x plus 1 equals 0. My usual method would be to factor it, but I can see pretty clearly there isn't a combination that's going to work. Would you agree two numbers multiplied together give you 1 are never going to get you -5? I mean, 1's just 1 times 1, right? The best you could do is probably 2, right? You're not going to get 5. So factoring's out the window, right? It's just not going to work. So how do we do quadratic formula? Well, the first thing we do is you identify the A, the B, and the C. A is how many x squared you've got. B is the coefficient of x, that means how many x's you've got. And C is the term, the number at the end, very often called the constant. So I'm going to use these numbers in that formula. Now, some people, and I'm not one of them, can plug all these A, B's, and C's into this formula and get both answers. But if I try that 50-50 chance, I'll screw up somewhere and one of my answers or both my answers are wrong. So I don't do it that way. What I do instead is I find just this piece first. See the bit inside the square root? It's even got a name if you go looking it up. Called the discriminant. Now, b squared is -5, so -5 squared. Take away 4 times a times c. And -5 times itself is plus 25. 4 1s is 4. And so I get the number 21. So that's what my b squared take away 4ac is. It's worth 21. What I can now do is I can take that and use it in my formula. Because my formula now becomes -b plus or minus the square root of 21 all over 2a. Normally I wouldn't write letters there, but would you agree that's a much easier formula to deal with? Right. Would you agree this guy here is easier to work with? Right. Now, what do? I just plug in the number a is 1 and the number b is -5. So the negative of -5 plus or minus the square root of 21 all over 2 times 1, which is 2. And then you split into your two questions, your two solutions. The negative of -5 is 5. So it's 5 plus the square root of 21 all over 2, and 5, take away the square root of 21 over 2. And there's your solutions. They're not very pretty, but they work. I'm not going to check them, but I know they work. Want to see another one? Are we good with this? You want to see another? So let's pick one from, there are only 10 homework questions, so let me pick one. And this is question 5.
Is it okay if we put it on the left side? I was trying to look at it.
Sure.
Thank you.
Rachel, have I always been too small for you? I mean, the thing. Is it?
No.
No? Are you just getting old like me and your eyes ain't as good as they were last week?
Pretty much.
Agreeing with me. That's not nice. Okay. Well, she's finishing off this one. Let's look at question 5. 2x squared, take away x, take away 3 equals 0. That makes a 2, b -1, c -3. I'm going to find the b squared, take away 4ac part. That's -1 squared.
Is that
Take away-
minus x minus 5?
That's a 3.
Minus x minus 3.
So it's -1 squared, b squared. Take away 4 times a times -3. -1 squared is 1. -4 times 2 times another -3 gets you plus 4, and it gets you plus 24. So altogether, the b squared take away 4ac part is 25. So find the discriminant first. And then we can do x equals -b plus or minus the discriminant over 2a. See, that formula is much easier to deal with because the ugly guy inside the square root is 25, so I can just use 25 there now. The negative of b is the negative of -1 plus or minus, oh, wait a minute, isn't the square root of 25 5? So it's a little bit nicer. And 2 times a is 2 times 2, which is 4. And so we'll split it into its two solutions. 1 plus 5 over 4. And 1 take away 5 over 4. Do you see the plus or minus get separated? Plus 5, minus 5. This guy is 6 over 4. 3/2. This guy is -4 over 4, which is -1. So we actually got, well, maybe I should write bigger. That might be an alternate way of figuring out this problem. I'll try and write larger because I'm losing the ball. So here's our two solutions, -1 and 3/2. You know, I could have solved that a different way. I could have solved that by factoring. And that would have gave me the same two answers. So just to show you that two different techniques work. Right, I'll try and write larger now. See if this helps. Okay. Have a look at this guy, question 7. If I write like that, is that big enough or do you need more, Rachel? I can write much larger.
A little bit bigger.
Okay. Will that work?
Yes.
Okay, so if I make them roughly 2 lines wide, that's going to help, right? So 8u equals negative 4u squared, take away 3. This question isn't even ready to have a quadratic formula done on it. Right, it's all jumbled up. Shouldn't I get it everybody equals 0, right? Standard form. So I've got some work to do before I even think about using the formula. As long as you do it to both sides, it's okay, Roll. So tell me what to do to both
Subtract
sides.
8u.
Oh, you want to go that way? That works totally correct. I just don't want to do that.
Could you add 3?
Yeah. And while I'm at it, add 4u squared.
Oh, because you want to deal with the negative.
Yeah, and oops, sorry, got my height. Make the next one nice and big. There we go. Yeah, I just try and avoid negatives. Right? I know my weaknesses. Aren't negative numbers more likely to cause you mistakes when you do calculations? So this fella here is 4u squared plus 8u plus 3 equals 0, right? Can you just trust me you can't factor this one, even if you use the magic cross, at least? Yeah, you can't do it. So A is going to be 4, B is going to be 8, and C is going to be 3. Isn't it just easier with positive numbers than negative? Now, what Sarah was saying earlier would have worked totally fine. You would have got the right answer when you just have a lot more negatives in your world. So it's not that that was wrong, because it works. Right, I'm now going to get the discriminant first. So b squared take away 4ac. 8 squared take away 4 times 4 times 3. Well, that's going to be 64. Take away 48. Oh, God, what number is that? Oh. Evidently, I was wrong. You can factor that. And that's fine. Quadratic formula doesn't care that I didn't do it as a factor. So I guess technically it's not u equals, right? It's not x equals, but it's going to be u equals. And it's going to be negative b plus or minus the square root of 16 divided by 2 times 4, which is 8. And I guess I'll need a new line for this one. It's going to be negative 8 plus or minus 4, all divided by 8. Let's do a split now. U is negative 8 add 4 over 8. And the other solution is negative 8. Oops. Take away 4 over 8. Those two guys at the top get you negative 4 over 8. Those two guys get you negative 12 over 8. You simplify the first one, you get negative 1/2. And if you simplify this one, I believe you get -3/2. So it actually works. You get nice answers. Well, relatively nice answers.
Can you fix the left paper?
I've got a thing which is my pole, which you can't see, but the thing my camera's on, so it kind of gets in the way. That's as straight as I can make it if I hold it like this. Actually, I could get rid of the x equals, and that gives you a few more inches there. Any questions about this quadratic formula? They're pretty much going to just be, I'm going to do a couple more and that's it. They're just going to get uglier and uglier, but the process isn't going to change, right? We're still going to do A equals B equals C equals. We're still going to get this discriminant, then we'll plug it in and see where the answer leads. So they're just going to be uglier and uglier versions of that same horrible question. I do not like the quadratic formula. It's very clunky. So my paper's out. See where we're off to next. It really doesn't matter which one I pick. I'll pick 10. Two x squared plus 7x take away 4 equals 0. Well, the good news is I can start the formula. A is 2, B is 7, and C is -4. B squared, take away 4AC, the discriminant is calculated first. It's going to be 7 squared, take away 4 times 2 times -4. That's going to be 49 plus 32. And that's going to be 81. So B squared minus 4AC is 81. That's a nice number. X then is -b plus or minus the square root of 81 over 2 times A, 2 times 2, which is 4. So it's going to be -7 plus or minus the square root of 81 is 9 all over 4. And that's going to give me two solutions. -7 add 9 over 4, or -7 take away 9 over 4. Top numbers get me 2, so 2 over 4. I get -16 for the top two numbers over 4. This guy gets me 1/2, and this guy gets me -4. So there are two solutions to this quadratic equation. If you plugged in 1/2 here, I bet you the whole thing would equal 0. If you plugged in -4 here, I bet you the whole thing would come to 0. They do work. Any questions about that guy? We good? Just one last one to do then. I think then I'll give you maybe just two to try it yourselves. I want the ugliest one I can find. Actually, I think I've done the ugliest one I can find, so I'll go to 6, which is the next ugliest. 15x squared. Take away 16x equals 15. Do I need to do anything to this before I can use the quadratic formula?
Get 15 on the other side.
Okay, so to get that, I'm going to subtract it from both sides. No. Oh, it is pretty ugly. A is 15. B is negative 16. And C is negative 15. I better have a calculator handy here. The discriminant part of the formula we calculate first, as we always do, which is that part. And it's going to be negative 16 squared, take away 4 times 15 times yet another 15, but the next time it's a negative. Whoa. Okay, 16 squared, or negative 16 squared, it's the same thing numerically. You get 256. This times this times this gets you a positive number. And 4 times 15 times 15 gets me 900. So that's 1156. Wow. I wasn't expecting that ugly an answer. Let me try something out here. Wow. You know that number? It's a perfect square. Its square root is 34. Oh, that's going to make this question a lot nicer than I thought it was going to be. So, x is negative b plus or minus the square root of 1156, all divided by 2 times a, all divided by 30. So here's our two solutions. X is equal to the negative of negative 16 is positive 16. Add the square root of 1156 is actually 34 divided by 30. And then it's going to be 16 again. The only difference is you take away 34. So these two look almost the same. The only difference is that one will be a plus that number and the others take away that number. The top numbers add up to give you 50 over 30, which simplifies down to 5/3. And the second one, that gets me negative 18 over 30, which I know I can do with 3. And I do it with 6. I can do it with 6. And that gives me my second answer. 5/3 and negative 3/5 are the solutions to this quadratic equation. And that is one ugly, ugly quadratic equation. So I'm going to give you 2 to try. And if there are no more questions, we will call that section done. So here goes. There's the first equation. There's your second one. Solve the last few seconds. Okay, let's go for it. I think the first one should have went pretty smoothly. At least I hope it did. I was planning it to do it. And you should have got really nice answers if you did it right. So A is 1, B is -11, C is 10. We'll find the discriminant part of the formula, which is this part. It's -11 squared, take away 4 times 1 times 10. -11 times itself is 121, and you're going to take away 40, and that gets you the really nice answer, 81. So we like that, because 81 is a nice number inside the square root. The quadratic formula then says that the two solutions are formed by using x equals the negative of b plus or minus the square root of 81 all over 2 times a, which is 2. So that's x equals the negative of -11 is plus 11. Add or subtract 9, square root of 81, all over 2. And that's going to get me two solutions in a few moments. It's going to be x equals 11 add 9 divided by 2, which I believe gets you 10. And the other one is 11 take away 9 divided by 2, which I believe gets you 1. Did you get 10 and 1? Because that's what you should have got. So you got it. You okay with that one? Right, good nods. I'm happy with nods. Right, you know I kept the second one is going to be the one that would have caused you the biggest trouble, right? There is a lot happening in this question. Right off the bat, don't we have to get everything on one side to equal 0? So I'm going to take away an x from both sides. And take away a 14 from both sides. So hopefully you did that first. Right? Subtract an x from both sides, subtract a 14 from both sides. Now, the quadratic formula in this question is going to use a equals 2, b equals 3, and c equals -14. And the b squared take away 4ac is going to be 3 squared take away 4 times 2 times -14. So that's going to be 9. And these two make it a plus answer. And 4 times 2 times 14. So I end up, oops, try that again. 4 times 2 times 14. I got plus 112. So altogether, 121, which is a nice number, isn't it? That works well inside the square root, 121 does. And our solution then is going to be x equals negative b plus or minus the square root of 121 all over 2 times 2, which is 4. And that's going to be negative of 3, because b is 3, so negative 3, plus or minus 11, because that's what square root of 121 is, all over 4. So we have two solutions. The first one, negative 3 add 11 divided by 4. That becomes 8 over 4. And that becomes 2. The other is not add 11, but it's the same numbers, but take away 11. And that's going to be negative 14 over 4. And that simplifies down to negative 7 over 2. Did any of you get to that one, which is a much longer, more messy one? If you did, you should have hopefully got the same answer as me. X equals 2 and x equals negative 7/2. So far, so good. I think we all deserve a 10-minute break. So I'll see you back here at 5 past. I'm going to get some ice, and then I'm going to get some. It's amazing I still have a job, isn't it? The number of times I insult my students. But you all know I like you, right? So it's just me being me. Okay. So this is homework 21. And we are going to be looking at the graphs of quadratic functions. Essentially, we're going to look at how do you sketch, how do you draw a quadratic function? And we're going to be doing it for different kinds of quadratic functions. They're all quadratic, but they have kind of different shapes to them. We're going to be doing it for things like y equals 2x squared and y equals negative 3x squared. We're going to be doing it for 2x squared plus a number, and things like 2x squared minus a number. And then the last ones are going to be fully fledged perfect quadratics. So these are all quadratic equations, and the reason they're called quadratic equations is, do you notice they all have an x squared of some kind in them? And we've already graphed straight lines. Basically, what you're going to do is you're going to find every single combination of points where the y coordinate is equal to twice the x coordinate squared. And in this case here, the y coordinate is negative 2, the x coordinate squared, take away 8 times x coordinate plus 7. And we are going to be sketching essentially all of these things. So let me show you some of the names that we use to describe quadratics. So imagine I've got a quadratic and it's already been sketched, and we don't need to worry about how it got sketched, but that's what the shape looks like. That's a classic quadratic function, right? Y equals f of x. Does anybody know what you call the bottom of the hill? It starts with the letter V. What's that guy there called?
The vertex?
You got it. It's called a vertex. Do you know the point where the quadratic crosses the y-axis? That point there.
Y-intercept.
Correct. And in this case, there happen to be two of them, but sometimes there's only one and sometimes there's none at all. But in this case, there are two of them. And these two guys, they're called the x-intercept. Since there are two of them, I guess, x-intercepts. If I want to do a very primitive sketch of a quadratic, if I could find these 4 points, wouldn't that be enough to draw a reasonably good curve? Right. There is a name for the whole curve. Does anybody know what that curve is called? Starts with the letter P. Have I heard that term? That shape is called a parabola. So if you ever hear me saying the word parabola, I'm talking about a big U shape or the upside down version of it. So this is what a quadratic looks like. And here are the names to the key features. There's one more key feature, which I'm going to draw as a dotted line right down the center of the shape. And it goes right through the vertex as well. And this vertical line is called an axis symmetry. All quadratic curves, all parabolas, have a line down the center that passes through the vertex, and the left and the right pieces, it's like a book closing, right? It's symmetric. You know, if you put a mirror there and look this way, it would look just like the whole shape. Now we are going to start with very simple quadratics, right? And then progressively, we won't get to these at all yet. And then progressively make it more and more difficult versions of that, right? I guess I'll keep this one here. Let's look at a quadratic that looks like that. And at the same time, I'm going to kind of do two together. And the other one's going to be negative 3x squared. The first thing that we're going to do to sketch these, and there's only going to really be two things. The first thing is we're going to get its shape. And the second thing we're going to get is its vertex. And the third thing we're going to get is another point. So when you have a quadratic and the number next to the x squared is a positive number, like 2x squared, 5x squared, 3/5 x squared, if that's a positive number, your quadratic will have this shape. It will look like a happy face, which is pretty much what this one is, right? Your parabola will be a happy face. If your quadratic is a negative number next to the x squared, right, we call that the coefficient. If it's a negative number, like we have here, negative 3x squared, then your guy, your parabola, will look like that. Now we have names for these two. This fella here is called concave up or concave upwards. And this guy here is called concave down or concave downwards. I think of it like this: concave up, right, goes up the way, concave down, comes down the way. That's how I kind of remember the names, right? Concave up, happy face, concave down, sad face. So sometimes I will say happy face and sometimes I'll say concave up. And other times I'll say concave down or sad face. Now, if you know what shape it is, isn't that going to help you draw a very simple sketch? We are not talking massively detailed sketches here. We are talking pretty crude, rough shapes, nothing too detailed. Certainly not anything as complicated as this. We're going to leave these guys to the last questions, which won't happen until next week. We're just going to do a 2x squared. So where does the vertex go when it's 2x squared? When it's only got x squareds in it, the vertex is at the origin. The shape, oh, let's suppose I'm doing this one, right? So I'm going through my hit list for 2x squared. What kind of shape does 2x squared have? Happy face or sad face?
Happy.
Happy, concave up. When it's 2x squared, the vertex is the origin. If it's 5x squared, the vertex is the origin, right? So the bottom of the happy face is going to be the origin, right? Now, all I need now is another point, and I'm going to do that by doing a little table. If you plug in x, can you see how y is also 0? Right. I need one more point. Give me the coordinates of, or give me an x coordinate I could use. And don't pick 42, make your life easy. Pick any x, 1, why not? I think 1 is a great number to use in every question. Now, if you plug in 1, won't the y coordinate be twice whatever the x coordinate squared is? So twice 1 squared, twice 1, it's 2. So there's my other point, 1, 2. Now, just with that information, happy face, there's your vertex, and one more point, I can draw, maybe not the neatest looking guy in the world, but there's my second point, there's my vertex. And I have now sketched our first quadratic. Now, it's not the most detailed quadratic in the world. Do you agree you're not going to get an awful lot of information out of that? But we agree also that at least it's a sketch of it. That's what it looks like. Now, same hit list, right? 1, 2, 3. Let's do it for y equals negative 3x squared, right? What's the shape of this guy? Happy face, sad face, concave up or concave down? What's the shape of that guy?
Sad face?
I can't hear you. You did say something. What was it?
Sad face?
You're right. It's a sad face. How do you know it's a sad face? What's the clue?
That's negative?
Yeah, that's all it is. If it's plus 5x squared, that's a happy face. If it's a minus 5x squared, that's a sad face, right? It's not that, it's not that difficult, right? It's pretty straightforward. Positive x squares are happy, negative x squares are sad. Actually, that kind of makes sense. If you're sad, you'd be negative, wouldn't you? Negative is sad. Positive, you're more likely to be happy. The vertex is the origin, because I tell you it is, and it is. And now I need another point. So I have an x, a little table, and a y coordinate. And if you plug in x, you get 0. I'm just doing that for completeness. And I'm going to pick 1, because I think 1 works really well for every situation. So I'm going to pick 1 for every situation. So what's the y coordinate? Negative 3 times 1 squared gets you negative 3. So that means I am looking at the point 1, negative 3. So let's see what my sketch looks like. So I have an x here, I have a y-axis here. I know the origin is the vertex, 0, 0. And I know 1, negative 3, I know that guy. And I know it's a sad face. Maybe not the neatest version of the world. But I've just sketched my second guy. So what's this going to look like when you do WebAssign, right? Because you know WebAssign, does things its own unique way. So let me show you some questions from the homework where you're going to be sketching these guys. I'm going to change this thing. I hope I do it without closing the wrong window. Okay, that's good. Okay. Oh no, shooting space. Okay. Hold that thought for a few minutes more. I want to get into student's view to kind of show you what it would look like from your perspective. Because, well, that's bad. Oh, go away, window. I'm fighting Windows right now, everybody, in case you're wondering what the heck's going on. So 21 and 22. Here we go. 21. Here we go. And there it is. So I'll move it over here. Right, I'll try that again. I have no idea what we're seeing right now. So are you looking at question 1 now? And it says x squared.
Yes.
And if I scroll down, do you see negative x squared? Let's pick one. Yeah, let's pick negative 4x squared, right? For example, right? Now, I've got negative 3x squared, right? And I did another one which was 2x squared. I'm just going to use this grid to show you how you type in the curves, right? If this had said negative 3x squared, you go to this window here, you see the one that looks like a happy face, and you click on it like that, so it's dark. And you plug in the origin, 0, 0. And then the other point I had was 1, negative 3. Oh. And that's it. Now, if you didn't hit the point quite right, you can go over here and you can make sure, right? Origin, yep. 1, negative 3. Do you see it's fiddling good? And then I would just hit submit answer. So let's close this guy up a bit. If I was going to do this one, right, which is a new question, negative 4x squared. Happy face or sad face for negative 4x squared?
Down.
Down, right? Wouldn't one of its points be the origin again? That's the vertex. And if I chose x equals 1 and I did it in my head, would you agree it's 1, negative 4? Oh. Let's say I'm not very good and I hit there by mistake, or it's jumping to whole numbers, that's good. Couldn't I just go over here and change it to 1, negative 4, right? So I could fix it. Now, once I'm happy where everything is and I've double checked by looking at my window, I would then go submit answer. Hey, I got it right. So far, so good. Now, let's look at this fella, 6x squared. Okay, agree that's a happy face, right? Concave up. Let's sketch it. The origin is the vertex, because I've told you it is. If I did, and I'm doing this in my head, but if I did x equals 1, what would the y coordinate be? For y equals 6 times x squared, what would the y coordinate be when x is 1? And don't overthink it.
6.
6.
There you go. And submit it. You see how quick these homework questions are going to be? If it's just 4x squared or minus 4x squared, aren't you just going to do the origin as a vertex and another point, like 1, make x1, and you've got your other point, and you're pretty much done. So let's move on to the next one in the chain. Let's do a little bit more difficult than those two, but just a little bit more. Let's do questions like question 3. Y equals 2x squared plus 4, and y equals 2x squared minus 1. So I'll start off shape. Vertex and another point. Well, the rule for shapes is going to be the same, right? So I'm going to do that one first, right? It says 2x squared here. The number next to the x squared is positive. That makes this guy a happy face. It's concave up. If it had been negative 2x squared plus 4, wouldn't it be a sad face or concave down? Does this number here, in this case plus 4 or negative 1, does that affect the shape? And the answer is no. Those two guys there don't change the shape. Rub them out, forget about them. As far as the shape's concerned, the only thing that matters is what's at the front here. Now, how about the vertex and another point? Well, we're going to change just a little bit. If you want to get the vertex, make x 0. That's actually what we did last time. And y will be 4. And while I'm at it, I want a second point. So this guy here, what you get when x is 0, that's going to be the vertex. So whenever it is 2x squared plus or minus a number, you get the vertex when the x is 0, right? You get the bottom of the happy face when x is 0. What do you think my second x value is going to be?
1.
And can you trust me that the answer is 6? Now, I'm going to nip back over to our WebAssign and imagine that that was the question, that we're being asked to sketch 2x squared plus 4. So pretend that says 2x squared plus 4. I have a vertex, right? So, oops, do that first. I have a vertex at 0, 4, and you plot that first. So always make the vertex your first stop. And then at 1, 6 is my second one. There you go. If you know the vertex and you know one more point, don't you know enough to draw a reasonably good sketch? Okay, another guy. He's shooting space. Try that again. I am so good at not swearing, aren't I? Years of practice. Okay. So how about the second question? This one. It's going to have a shape. And it's going to have a vertex. And it's going to have another point. Okay. Would you agree that this is exactly the same as the other one? Isn't it a happy face again? If I do a quick table, I should get the vertex and another point now. If you plug in 0, the y value is -1, and that's the vertex, right? It's at that coordinate. Pick x is 1, plug it in here, you get 1. That would be your second point. And can you imagine that this is Webersine? 0, -1 would be about here. And 1, 1 would be about here. There would be, oh, okay, there would be my sketch. As long as I know the shape and 2 points. In fact, if I tell Webersine the vertex and a point, it's going to figure out the shape for me, but it's good for human beings to know what the shape is. We've got time for some more of these, but a little bit different. They're still in the family that looks like these guys, right? It's so many x squared plus or minus a number, right? Okay, let's cut some corners here. What shape's that guy going to be? What shape is this quadratic?
A down one?
Okay. Kind of sad. Concave down. Set up in my little table. I only need the vertex and one other point. Don't you get the vertex by picking 0? And if you plug in 0 into here, you get 1. So that would be a vertex at this point here, right, at 0, 1. I don't think I'm giving anything away by saying, aren't I going to pick 1 again? And if you plug 1 into here, can you trust me that you get -2? So that tells me that at 1, -2, we get the second guy, and we know that it's a sad curve. Once you do enough of them, isn't it quite easy to draw a very rough sketch of a quadratic? Just tell me its shape, its vertex, and one more point. That's the last one for today. Okay, what kind of shape are we talking about? What shape is this guy?
Is it also going to be down?
Yeah. How do you know? Where do you look to find out?
Because they're negatives.
And is it this negative that makes it down or this negative? Is it the -2 that's important or the -4?
-2, I think.
It is. It's the number next to the x squared. So that's negative is what makes it concave down. When that was positive, didn't it make it concave up? So if you plug in 0, you will get the vertex, which happens to be -4. And if you plug in 1, you get -6. And if this was Webersine, you would always plot the vertex first. So 0, -4 would be here. Of course, I never plan well, do I? And at 1, -6, you put your second one, and we know it's a sad face, so we know it goes like that.
Can you move the paper a little bit higher?
If you were going to do a better sketch, so something that was a little bit more detailed than this, do you know the only thing you would change? I wouldn't do just another point. Couldn't I find 5 or 6 points? Couldn't I do x is 2, x is 3, x is minus 2, x is minus 3, right? Plot 5 or 6 or 7 or 8 dots. And if I did that, wouldn't I just get a much more accurate curve? But apart from that, it would be pretty much the same process. And since we're only interested in very rough sketches, this does the job. That's kind of the bare minimum, right, that you need. Shape, vertex, and one more point. And perfect timing. Say hi. And bye-bye. I'll hang about if there's any questions, of course. Rachel or Dawn, got a question? Are we good? We're good? You're good as well? Then I will close off for today. Have a nice day. Or a nice evening.